Okay, so I guess we'll go through a few things that we're working on. Obviously, I got another digit on my clock counting, and as you can see, I have it counting to 60 instead of counting to 100, 00 to 99, and then resetting. So I got that finally working with the seconds and the decaseconds, and it's counting to up to 59 and then resetting. I was having some problems with the code, and this coming to 59, and then it would go 60 for I don't know about I don't know maybe 100 milliseconds, and then it would show 00. So I had to put another IC in to send a signal to this counter to zero it, so that my eye doesn't see it. So, but if I were to pull the diode out, the signal diode out, you'd actually be able to see it count to 50, 60, 60 for just a moment, and then it would change to 00. And that was using the code, and I probably just wrote something wrong and or didn't write it, put it in the correct order or something. Can't seem to get it to work, but as you can see, I got it to work here by just adding an extra IC on the outside of it. So here it is. It's a 4017 I added, which is a decade counter, so I'm keeping track of how many times the carry out it goes through here, and when it carries out the sixth time, the 4017 counts the sixth time, and it resets everything to 0 on the decaseconds, so it comes back down to here. So it's just a work in progress still, but I'm making progress on that. The other thing, actually, I built something else also, and then one more project after that. This is something I built. I've been wanting to use these radio frequency guys for a long time, and I think they're 433 megahertz or kilohertz. I forget which one it is. I have to look. I should know that, but I don't off the top of my head. I've had them for a long time. Let's see here. We got resistors in the way. .433 megahertz. So anyway, so it's over there sending its wireless signal. So it's going from the sender to the receiver right there, and you can't tell, but this light's actually flickering. I should probably put it, I wish I had it hooked up to the oscilloscope, but my bench is a complete disaster. And there was a little thing of going around and saying, what's on your workbench? And I'm like, I'm not showing mine. Mine's a complete disaster. It's too many projects, too much stuff going on. So anyway, so I'll just briefly explain to this. So we got the 9-volt battery powering it through a 7805, and obviously the capacitors are just aiding in the surging. I believe that's called a decoupling capacitor. And then it goes, feeds the rails, obviously the positives and the negatives, and then I got them being fed all the way through across. And I wanted to make it really stable, and that was my goal. Oops, there goes the tool. So I wanted to make it really stable and not have any problems with sending false signals. And what the goal is to send a bit and light up this LED right there, the green one, by pushing this just button right here. And that was just my goal. So I just wanted to send a signal to go ahead and send that. I can hold it down, and you can see it working. So I can just barely nick it, and this LED indicates that this button has been depressed. And then this one is actually flashing, and this is a 555 is an oscillator. I forget what it is. It's like 13 milliseconds on, 13 close to 13 milliseconds off, because I put a diode right there between the two pins to try and with the two resistors at 10K each, to try and make it as the waveform as close to the on and off cycles as close as possible, make it a true 50-50. But anyways, so that's actually going on and off, and that's sending that on and off signal to this wireless signal. This yellow wire was to hook up the oscilloscope, and that's setting a signal over to here. And this is actually blinking too. You just can't tell. It's just blinking so fast that it's just hard to tell. And then what it's doing is this signal, this blinking, is actually going into this resistor and on this pin of this another 555, which is set up in a one-shot mode. Also, I have this capacitor in here, so I believe this is some kind of an RC signal. And basically what I was trying to do is keep this pin positive, the trigger pin positive, so that you can see it there. There it goes. So that it stays, it doesn't trigger it. And then when this goes negative, it the capacitor drains off fast enough to back through the resistor back into this pin, because this whole thing went negative through here because I'm sending a 0, and because this is hooked up backwards. Actually, this is actually hooked up to positive. See, it's actually positive, and so when that goes 0, that stays on. It gets brighter. You can see it's getting brighter because it's not flickering or oscillating, and it's just constantly staying on. And so the chip is sourcing the LED to keep it on. And sorry, did I say sourcing? I meant to say sinking. Sorry, it's sinking the current from the positive rail into the receiver. And when I hit the button, it triggers the one shot for about I don't know, roughly a second. I don't calculate it out, but it's roughly a second. It's really close. And then this indicates that the 555 is currently not in the on position, and when I hit the, that would be my signal saying it's on and receive the signal, and the 555 keeps it from any switch bounce. There it goes again. What I'm doing over here with this 555 is I'm actually triggering, even though it's oscillating, this blue one. See, let's see if we can get it to make a little bit brighter here. It goes, oh, just flat out off, sorry. Just flat out off, so that's easy to see. It's very, very noticeable. And you see this green LED lights on, meaning I'm pushing the button, and that turns off. And you can see that it's very evident here by the video. But I'm actually just using the reset pin, which is the number 4 pin. You can see the green wire here on the reset pin to the momentary button, and that's how I'm interrupting the 555 from oscillating, just like that. And the reason I'm oscillating is because it was my understanding that these things need to have a constant signal on and off, and happening rather rapidly, to help stabilize them. Otherwise they can just kind of float around and pick up false signals. But really tapping it, trying to get it to trigger a false signal or anything like that, but it's pretty stable, and push the button and there it goes. And so that's one of the other projects I was working on. Another project I was working on involves a remote control with a relay to a flip-flop, and I use one button on the remote to turn on a bunch of 12-volt LEDs to light up the interior of the van, to make it easier to load Lisa, so that it's really bright in there. And one of the things we often do is when we're offloading Lisas, we forget to turn the lights off. So I can just use the remote, which is an RF signal, so it goes relatively far, like 300-400 feet. And I can just push the button when we're inside the house, and it shuts the lights off inside the van. And it just involves one button because I'm using the flip-flop. Also, that's called like a half adder. I don't have that project here. It's already installed in the van. So, anyways, those are these projects.